Okay, small change here, so look at the problem. X squared plus 4 equals 9 instead of x plus 4. Made it quadratic because that's what you'll be more likely to see. All right, so we subtract 4. Inequalities, solve them just like you solve anything else. Algebra is not going to change as far as what you have to do to get the answer. So we're trying to get x by itself. Now, x squared is greater than or equal to 5. If I want to know what x is, I have to get rid of a squared, so I have to square root. Anytime you square root anything, you've got both a positive answer and a negative answer. So I always like to just throw that negative one over here on this side. And then the quick way to decide, okay, because it's greater than and less than, all those signs, do I need to be in between these numbers or do I need to be outside of these numbers? So I like to pick an example, plug it in, and see where I'm at. So pick a number between negative square root of 5 and positive square root of 5. Generally, think of 0 as being in between. That's a pretty easy one. So plug in a 0 and ask yourself if it works. Does 0 squared plus 4, is that number greater than or equal to 9? 0 squared is 0, plus 4 is 4. 4 is not greater than or equal to 9, so you are not going to be in between negative square root of 5 and positive square root of 5. You are not going to be in between them. You are going to be every answer other than that, and you can plug a couple numbers in after you do it to make sure that it works. So how do you write that? Well, every other number would be the smallest number you could think of until you get to negative square root of 5. And then there's a gap. None of those get to count. And then the square root of 5 all the way to any number you can possibly think of on the bigger end. So if it doesn't work when you plug a number in between, make sure that you tell me that's not it, it's the everything else. So that would be your solution. You could pick any number on bigger or smaller than the square root of 5, and you could plug it in and see that it was true. And generally, if you have a greater than or equal to sign, as opposed to just a greater than sign, you use a bracket to signify that it's included versus not included. All right, same problem or same idea, just a couple extra steps here. So on this one, again, think about what you would have to do to solve. You're going to add 3. Think just algebra. What would you do in any other situation? Forget the fact that it's not an equal sign for a minute. Square root. Now, the square root of 16 is 4, but don't forget that any time you take a square root, you also have the negative answer as well. So the square root of 16 is 4 and negative 4. So I'm just going to put that over here on this other side. And now you still have to subtract 2. So don't forget to subtract 2 to the 4, but also to the negative 4, because they're both the square root of 16. So 4 minus 2 is 2. Negative 4 minus 2 is negative 6. And again, pick a number in between negative 6 and 2 and just see if it works. An easy number to pick, again, would have been 0. Zeros are usually pretty easy to plug in. So 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So 1 is greater than or equal to 13. That would be not true. So we're not going to pick the numbers in between negative 6 and 2 for our answer. We're going to pick all the numbers beyond negative 6 and 2. So any number smaller than negative 6 up until you get to negative 6, bracket to show that it's equal to. And then you have a gap. You pick back up again at 2, and any number bigger than 2 will also be an answer. And again, if you want to make sure that your answer's right, pick a number that's in the interval that you gave. Like, how about 5? 5 is bigger than 2. Does 5 work? If 5 works, you can kind of be more confident that what you did is right. So plug a 5 in. 5 plus 2 is 7. 7 squared is 49. 49 minus 3 is 46. 46 is obviously greater than or equal to 13. So, again, you can kind of be confident that what you gave me is an interval that's correct.